I'm going to do a video on probability, and what I'm going to do is I'm going to break this into 4 parts. So each part is a different color. So measuring probability is going to be in blue. Part 2, experimental versus theoretical probability, is in purple. Counting principle and sample spaces is supposed to be in orange. And then the last one is compound probabilities, and that will be in red. So if you are not interested in this whole video, because I'm sure it's going to be kind of long, skip to the part that you need. All right, so part 1, here we go. Probability is measured between 0 and 1, and if you have the probability of something happening and it's 0, it means it's impossible. So for example, what is the probability of flipping a coin? Flip a coin and get and have it land on rock. Flip a coin, have it land on rock. I shouldn't put that there. And the obvious answer is 0. It is going to be 0 because there are no rocks on the coin. It is heads or tails. So if I said, what's the probability of flipping a coin and getting a head or a tail? That is going to be 1 because it's always going to happen. If I said, what's the probability of getting a head? It would be 1/2 or 0.5 because it is equally likely to get a head or a tail. All right. Now, if it's less than 1/2, it's unlikely to happen. And the more unlikely it is, the closer it is to 0. So, for example, if I said, I'm going to roll, well, let's say I'm going to roll 2 dice. And I want to know what is the probability of getting the sum of 11. All right. So the only way you can get 11 is the 5 and a 6, or a 6 and a 5. So the probability, believe it or not, there's 36 different ways to roll 2 dice. It's going to be 2 out of 36, which is 1 out of 18. That's very unlikely. It's unlikely that you're going to get an 11. If I said, what's the probability of getting a 7 when you roll 2 dice? Well, you can get, that's going to be 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 6, or 6 and 5. That's 1, 2, 3, 4, 5, 6. Oh, what am I doing? That's not true. That's supposed to be 5 and 2. That's 6 and 1. My 1, 2, 3, 4, 5, 6. Let's say 7 or greater. Say the probability of getting something greater than 7. So those are all the ways you can get 7, but then you can get 8 by doing 2 and 6, 3 and 5, 4 and 4, 5 and 3, 6 and 2. You can get 9 by doing 1, 2, 3 and 6, 4 and 5, 5 and 4, 6 and 3. You can get 10 by doing 4 and 6, 5 and 5, 6 and 4. You can get 11 by doing 5 and 6, or 6 and 5. And then you can get 12 by doing 6 and 6. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 out of 36 is going to be, when we reduce that, it becomes 7/12. That is likely to happen. It's more likely to happen than equally likely. So that's it. That's kind of where those things fall. All right. Now we're going to talk about experimental probability versus theoretical probability. Let's say I have this spinner. Now imagine that this spinner is drawn properly and that these 5 sections are all equal. And it comes up, when I spin it a bunch of times, it comes up red 18, blue 26, yellow 20, green 12, and purple 24. Well, experimentally, if I said, well, what's the probability that's going to come up, let's say purple, let's say red. We'll say red. Red, we would say that's 18 and this is based on our experiment. It's going to be 18 out of, let's see, 18 plus 26 is 36, 44, 44, 64, 76, 86, 96. Oh, 18 out of 100. So it's 18 out of 100. So I said, okay, well, what would happen if I were to spin this 500 times? What would be the probability of getting a red? How many times should we expect a red based on our experiment? So based on our experiment, if I spun it 500 times, we would do this, and we'd cross multiply. You need to get 100x equals 18 times 500. So 100x is equal to 0, 0. 18 times 5 is 90, so that's 9,000. We would divide, we divide by 100, and so x would equal 90. So based on our experiment, we should come up with red 90 times. Now, that's an experiment, so now we're going to take a look at the theoretical. This is what should happen. Because I have 5 spaces and I said they were equally spaced, the probability of getting a red is going to be 1 out of 5. So if we were to do this 500 times, what should happen is we should get 5x equals 500. You just cross multiply, and we get 100. So theoretically, it should have come up 100 times. Based on our experiment, we would expect it to come up 90 times. The theoretical is what should happen, and the experimental is what we think happened, or what we think based on our experiment. All right, the counting principle and sample spaces. There's more than 3, but there's 3 ways I like to do sample spaces. I'm going to flip a coin. I'm going to flip a coin once, and then I'm going to do a spinner. So flip a coin. And then I'm going to do a spinner with the numbers 1, 2, 3, 4 on it. All right, so for a tree diagram, what it would look like is, since I'm going to do a spinner, it'd be heads or tails. What could happen if I did heads? Well, I could get 1, 2, 3, 4. And if I did tails, I could get 1, 2, 3, 4. And that's it. So those are all the possible outcomes. And if you follow the branches, we get... well, that's too big. Let's see. Oh, here we go. We get heads 1, heads 2, heads 3, heads 4. That's 4 ways. Tails 1, tails 2, tails 3, tails 4. That's 8 ways. If I wanted to make a table using the same data, it would look like this. I could say, well, I could get a heads or a tails, and I could get 1, 2, 3, 4. And some people like this a little bit better because it's a little bit easier in some ways. Heads 1 or tails 1. Heads 2, tails 2. Heads 3, tails 3. Heads 4, heads 4, tails 4. And those are all our samples. The list is kind of the same exact thing. Heads 1, heads 2, heads 3, heads 4, tails 1, tails 2, tails 3, tails 4. And that's kind of our list. I'm going to do one more. Well, maybe I won't do one more because I'm kind of running low on time. The last thing I'm going to talk about is compound probabilities. So here's the deal. Oh, I'm sorry. There is one other thing I wanted to talk about. You'll notice I have 8 outcomes. Now, the reason why I have 8 outcomes was because there is 2 ways of doing the first thing, and there was 4 ways of doing the second. So what that means is I can get a heads or a tails. So there's 2 ways of doing the first thing. and then there was 4 ways of doing the second, and then if I got a heads, there was 4 ways, and if I got tails, there was 4 ways. So there was 8 possible outcomes. So finally, the last thing I'm going to do is this. I'm going to look at compound probabilities. If tomorrow it rains, there's a 0.2 chance that it's going to rain. So that means because there's a 0.2 chance that it will rain, there's a 0.8 chance that it will not rain. Well, if it does rain, I was hoping to go for a bike ride, but if it does rain, I'm probably not going to go for a bike ride. I'm going to say that there's a 0.1 chance that I'll go for a bike ride outside, which means my alternative was to go to the gym, which means there's a 0.9 chance of me going to the gym. Now, if it doesn't rain, Hazel, come on in. Sorry. If it doesn't rain, the probability that I'm going to go to the gym is 0.3, which means the probability that I'm going to ride outside is only 0.7. So now this kind of depends on what's happening. So what is the probability that I'm going to go to the gym? We'll say that it's going to rain, and then I go to the gym. Well, what we do is it has to be 0.2 times 0.9, which is 0.18. And the reason why is because, remember, I can do one thing first, followed by another. Now, if I want to know what's the probability that I'm going to go to the gym, or no, let's say I'm going to ride outside. The probability that I'm going to ride outside. Well, that can happen 2 ways. If it rains, then it's going to be 0.1 that I go to the ride outside. But if it doesn't rain, that's going to be 0.8 times 0.7. So I had to add, because this is going to be if it rains or if it doesn't rain. And so here I got 0.02, and here I get 0.56. And so the probability will be 0.58. This one was a little bit trickier. But that's how it works. All right. Hopefully this helps. And I'm going to stop there.